Everyone, in this video I will talk about array marking technique to solve certain type of array problems. Okay, so that's why I've taken an example. I've taken a problem that I'm going to solve this using array marking technique, but because we are going systematically, so we will start discussing this problem. Okay, and we will try to solve it using very simple brute force approach, and therefore we will try to optimize it, and at the end we will discuss the array marking technique. That is our goal for this video. Okay, so the question says that you have given an array of size n. Okay, so let's say the size of the array is n. Okay, and you have given an array. Okay, and and the element of an array will be in the range from 1 to n. Okay, let's say here n is what? N is 5. So the element will be either 1 or 2 or 3 or 4 or 5. Okay, so the element of the array can be from 1 to 5. Okay, and we have to find those elements in the range from 1 to n, from 1 to 5 for this example, okay, that has disappeared. Okay, so let me take an example. So let's discuss the problem with this example. Okay, so I've taken an array of size 8, and you have to find those elements in the range from 1 to 8, in the range from 1 to n. Okay, you have to find those elements which are disappeared, which are not present here. Okay, so what are the elements in the range from 1 to 8? That are 1 2 3 4 5 6 7 and 8. Okay, you have to find that element which are disappeared here. Okay, so let's check for 1 is present or not. 1 is present, yes. What about 2? 2 is also present. It is present twice, but doesn't matter. I have to find whether 2 is present or not. It is present. Okay, let's check for 3. 3 is also there. What about 4? Yes, 4 is also there. 5. Oh, 5 is missing. 5 is not present in this array. 5 has not appeared in this array. So I will say 5 is the element in the range from 1 to 8 which is disappeared, which is not present here in the array. Okay, so 5 is the element which is missing. Let's check for 6. So 6 is present. No, there is no any 6. Okay, so I will say 6 is the element in the range from 1 to 8 which is missing, which is not present in this array. Okay, which is disappear in the array. So now let's check for 7. 7 is present. For 8, yes, 8 is present. Yes, so these are the two numbers. 5 and 6 are the two numbers in the range from 1 to 8 which are disappeared from this array. Okay, I hope you are getting this. Okay, in the question it is granted that the element will be in the range from 1 to n. Okay, that means there will no any element that will exceed the n or lesser than 1. Okay, the element will be in the range from 1 to n. It is granted in the question. Okay, let's take another simple example that you have given an array of size 2 and the elements are 1 and 1. Okay, these are the indices. You have given an array of size 2 and you have to find the elements in the range from 1 to 2 which are missing. So what are the elements in the range from 1 to 2? That are 1 2. Only 2 element is in the range from 1 to 2. So 1 is present. Yes, 1 is present. What about 2? 2 is missing. So 2 is going to be the output. Fine, 2 is going to be the output for this test case. Okay, Okay, so let's discuss the solution. What will be the solution of this problem? Okay, I mean, how we will code it. Okay, so the very basic brute force is you will run a for loop from 1 to n. Okay, you will run a for loop from 1 to n, and you will check for each element it is present or not. If it is present, you will simply break and do nothing. But if the element is missing, then you will keep the element. Okay, you will keep the element in vector, and at the end you can return it. So what I'm trying to tell you is, you will run a for loop from element equal to 1 to n, and you will check whether the element is present or not. Okay, if the element is present in this array, okay, so I will write a function named is present into linear search. Okay, I will do linear search because array is not sorted, so I will pass my array and the element. Okay, so this function basically checks whether this element is present or not in this array. If the element is present in this array, in this case our is present function will return true. Okay, and in this case I will do nothing. But if it is not present, then in this case I will store the element in some vector. Let's say I have declared a vector v, so I will do v dot push back the element. Okay, so this is the very basic approach that you can think of. Okay, but what about the time complexity of this solution? Okay, because I'm running a for loop from 1 to n, and I'm searching an element in the array, so this will take n and this will take n for each element. Okay, so the overall time complexity is going to be bigger of n square. Okay, so this is the brute force solution that you can think of. Okay, but will it further be optimized? Okay, so can I optimize it somehow? So let's think of optimization. So the one optimization that I can do is, I can use the set data structure, rather unordered set. Okay, so I will use the unordered set data structure, and in this unordered set we will store all the elements. Okay, but by the way, why I'm using this unordered set data structure? I'm using this because I can search the element in constant time. Okay, here I am wasting my bigger of n time. So here the is present function will take bigger of n time to search an element. Okay, and because we have to search n elements, that's why our time complexity was bigger of n square. But when we use on the unordered set data structure, then this search cost will be reduced to bigger of 1 in the average case. Yes, so what I will do is, I will store all the elements of this array to this unordered set, and after that, instead of searching an element to this array, I will search the element in the unordered set. Yes, I can do this. So in this case, our time complexity will be reduced to bigger of n. Okay, so what I'm trying to tell you is that I will use a set data structure, and I will store every element of this array to this unordered set. Okay, so let's store all the elements. So the elements are 4, 3, 2, 7, 8, 2, 3, 1. So these are the elements. I have stored it in this unordered set, and instead of searching the element using linear search that took more time, I will search the element in this unordered set. Okay, so I will simply search the element in from this unordered set. So for that, what I will do, I will write if let's say the name of the set is us. Okay, so us dot find element. Okay, so if the element is present in this unordered set, it will not return us dot end iterator. So in this case, the element is present in the unordered set. So if the element is present, I will do nothing. But if the element is not present, I have to store that element. Okay, so I will do equal. Okay, so if the element is not present in this unordered set, then I will store the element in the vector. So I will do v dot push back. I will store the element. Okay, and at the end I will return the v. Okay, so let's code it whatever we have seen till now. So what we were doing, we were running a for loop for element equal to 1 and element will go up to n. Okay, so let's declare the n is the nums dot size. Okay, the size of the vector, and we'll do element plus plus. Okay, so we will check whether the element is present or not in this nums array. If the element is not present, we will try to save the element in some vector. So let's declare a vector of int answer, and we'll check if the element is present, and we will pass the nums array and the element. Okay, so if the element is not present, so it means if it is equal to false, that means if the function returns false, then we will save answer dot push back element. Okay, and at the end we will return the vector, the answer vector. Okay, so now let's write the isPresent function. So let's declare it private. Now let's write the function isPresent. Okay, so the return type is bool and is present. Okay, so we'll show the vector and the element. Okay, so we will simply do the linear search. So we'll run a for loop int I equal to 0 up to nums dot size I plus plus. Okay, so if the nums of I is same as the element, we will return true. That means the element is present. Otherwise, at the end, after running the entire loop, if the element is not found, we will simply return the false, that element is not present in this array. Okay, so now let's run it and let's see. It is running fine. Let's try to submit it. I think it will give TLE. So it is throwing an TLE, the time limit exceed. Okay, or so let's try to modify it. Okay, so what we were doing, we were declaring an unordered set. Okay, so let's declare it unordered set of integer. Okay, and let's name it us. Okay, so first thing that we'll do is we'll try to save all the elements of nums in this unordered set. So we'll do for auto element from the nums. Okay, all those elements that belongs to the nums array, we'll try to save it in the unordered set. So us dot insert what, the element. Okay, and instead of searching the element in the using this linear search, we will simply remove it, and we will search the element from this set. Okay, so if us dot find element, if it is equal to us dot end, that means the element is not present in this unordered set. So if the element is not present in this unordered set, we'll save it in my answer vector. Okay, so let's run it. Let's see. A small typos. So yeah, let's run it. Okay, so it is also getting accepted, so let's submit it. Okay, so yeah, it got accepted. Okay, so I hope you have understood the code. Okay, so till now we have seen two approaches to solve this problem. Okay, so first one is we have seen that for each element in the range from 1 to n, we are searching whether the element is present or not in the array. So the linear search takes bigger of n time, so the overall time complexity has become bigger of n square, because for each element, because for n elements we are searching that the element is present or not. Okay, so that takes bigger of n square time complexity, and in this approach we are not using any extra space. I mean, we are using only constant extra space. Okay, so in the first approach the space complexity is bigger of 1, and in the second approach we are using an unordered set. Okay, because we are using an unordered set. Why we are using unordered set? Because average search cost is constant time. Okay, so that's why instead of searching the element in the array, we are searching the element in this set. So in this case the time complexity is big of n, but when we talk about the space complexity, so because I have stored all those integers that are present in the array, we have stored all those n integers in this set. So the extra space complexity in this case, in the second approach, the extra space complexity is going to be bigger of n. Okay, so can we further optimize it? Can we further optimize it? Can we do this problem without using this extra space? Okay, without using this extra space, can we solve this? So the answer is yes, and that can be done by array marking technique. Okay, so let's discuss the array marking technique that will solve this problem efficiently. Okay, so I have taken the same example, the same array of size 8, and let's discuss about the array marking technique. Okay, in the question we have to find all those elements in the range from 1 to 8 that are not present in this array. Okay, so the elements in the range from 1 to 8 are 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so instead of searching the element in this array, can I save the information that 4 is present in this array? Can I say that 3 is present in this array? Can I save this information? So as I've said that I don't have to use any extra space. So how will I do this? Using only constant extra space. Okay, so in the array marking technique we will try to save that 4 is present in this array. We will try to save the information that 3 is present in this array, and you already know that the array element can be in the range from 1 to 8. That means there is no any element in the array that is greater than n or less than 1. Okay, so this is the restriction that you are given, this is the constraint that you are given. Okay, so can you use this important fact that the array element lies in this range only? So how can you store whether this element is present or not? Okay, how can you store this? So because the array element is in the range from 1 to n, and you know that the array indices are from 0 to n minus 1. Okay, for n equal to 8 the array indices are 0 1 2 3 and so on till 7 till n minus 1. So can I use these indices to represent the array elements? So what I'm saying is that can I use this index 0 to represent the element 1? Can I use this index 1 to represent the element 2? Okay. Can I use this index 2 to represent the element 3 and so on? And for index 7, can I use the index n minus 1 to store the element n? Okay. So how can I use this? Okay. Because 4 is present, so how can I store the information that 4 is present? So because we know that index 3 will represent the element 4, so can I mark this index 3? So can I mark index 3 that 4 is present? So can I mark a negative sign to represent that 4 is present? Okay. So if the element is 3, so can I mark the index 2 that represents the element 3? Can I mark this 2 as minus 2? That will show you that 3 is present. So the negative marking will show you that the 3 is present. Okay. Similarly for 2, okay, just consider the absolute part, the positive part. Okay. So 2 is present. So can I mark at index 1, whatever the element is, can I mark this element as negative just to represent that 2 is present? Okay. Similarly for 7, can I mark index 6 to be negative just to store this information that my 7 is present? Okay. So similarly for 8, can I mark this 7 as negative? Similarly for 2, can I mark the index 1 as negative? So because index 1 is already negative, so it means 2 is already present somewhere. Okay. And for this 2, I've already marked at index 1 to be negative. Okay. Now for 3, can I mark index 2 to be negative? So in this index 2, whatever the element is, it is already negative. So it means before 3 there must be 3 already present. That's why the index 2 is already marked as negative, and for this 3 I've already marked this 2 as negative. Okay. So now for this one, I can mark the index 0 to be negative. That will tell you that 1 is present. Okay. So finally the element at index 0 is negative. That means 1 is present. Okay. Because the index 0 represents 1. So if the index 0 is negative, so that means 1 is present. So yes, 1 is present. Index 1 is negative, so 2 must be present. Okay. So here is 2. At index 2 the element is negative, so it means that 3 is somewhere present in this array. So yes, 3 is present. Similarly for 3, the element is negative, that means 4 is present. Yes, 4 is present. Similarly for 4, the element is positive, that means there are no element which is 5, because if 5 would have been present here, then at that time at index 4 I would have been marked this 8 as negative, but there is no any 5, that's why it is positive. Okay. So at index 4 the element is positive, that means 5 is missing. Yes, that means 5 is missing. Okay. Similarly at index 5, 2 is present, this element is not negative, this element is positive, that means 5 plus 1, that is 6. 6 is not present here. Okay. Because if 6 would have been present in this array, then at index 5 I would have been marked this 2 as negative, but there is no any element 6, so why I will mark this index 5 as negative? So that's why it is positive, because 6 is not present. Okay. So 6 is the element which is not present. Okay. Similarly for 6, the element is negative, whatever the element is negative. So I can say 7 is present somewhere, so yes, 7 is present. Similarly for index 7, the element is negative, so that means 8 is present, so yes, 8 is there. So I hope you know that how you will find the element in the range from 1 to n that are missing. If at index I, if the element is positive, so that means I plus 1 is missing. Fine. If at index 4 the element is positive, that means 4 plus 1, that is 5, which is missing. So I hope you got the intuition that how array marking technique works. Okay, so what I'm saying that for every element, okay, for every element, that means from 0 to n minus 1, okay, the index will be the element, that means arr of I minus 1. okay, so if the element is 4, so 4 minus 1 will give you 3. So at index 3 you will mark the element to be negative. Okay, but if arr of I is already negative, so you will take the absolute part, that means the positive part you will take, and if you do the minus 1, it will give you the index for this element, and at that index you can mark the element to be negative. Okay, so if the element at this index is already negative, if it is already negative, so in this case you will do nothing. But if it is not negative, if it is already positive, then only you will mark the element as, that means arr of index as minus of arr of index. Okay, so in this way you can mark the elements to be negative, and after that you will simply run a for loop from 0 to n minus 1, and you can check if arr of I, if arr of I is positive, then in that case you will store the I plus 1, that this is the element that is not present. Okay, you will declare a vector v, and in the v you will do push back, and at the end you will return the v. Fine. So I hope you understood this solution. I hope you understood the array marking technique. And here if you are confused that why I have taken the positive part of the array, okay, so let's see. For 4 I will go at index 4 minus 1, that is 3. So at index 3 I will mark this 7 as negative. Okay, similarly for element 3 I will go at index 2 and I will mark this 2 as negative. Okay, similarly at index 2 my original element was 2, okay, not minus 2. Because I marked this 2 to be negative just to show that 2 plus 1, that means 3 is present. That's why I marked this 2 as negative. But my original element was 2. That means when we take the absolute part, that means the positive part of this element, then only I will get the original element. Okay, so original element 2, if you 2 minus 1, then we'll get at x1 is negative. So that 2 plus 1, that means 2 is present. Okay, that's why I've taken the absolute part. Index 2, the element is minus 2. So when we take the absolute part, it becomes 2, which is our original element. Okay, if I minus 1, I will get index 1. Index 1, I will mark this 3 as negative. Okay, so I hope you understood the entire solution. So in array marking technique, if the element is present, so we were marking the element minus 1th index to be negative. Okay, so what I'm saying is for each element of the nums array, so int I equal to 0, I lesser than n, I plus plus. Okay, basically n is the size of the nums vector. Okay, So what is the element? So nums of I is the element. Okay, so what is the correct index for this element? The correct index is the element -1. Okay, so this will become the index. Okay, so the nums of I -1 will act as an index for nums of I. So int int equal to nums of I -1. So as we were taking the positive part of it, so let's take the absolute part. Okay, so at index int, whatever the element is, if it is positive already, mark it as negative. So nums of int equal to minus of nums of int. Okay, and if the element is already negative, then we will do nothing for that element. Okay, so now let's declare a vector answer. So that we will run a for loop for I equal to 0, I lesser than n, I plus plus. Okay, so if nums of I is positive, that means what? That means I plus 1 is missing. Okay, so we'll save it into the vector. Okay, push back I plus 1. Okay, and at the end we will return the answer. Okay, so now let's run it. Yeah, it is getting accepted. Let's try to submit it. Okay, so it got accepted also. Okay, so I hope you've understood. Okay, and when we talk about the time complexity of this solution, then we were running a for loop for n times. So this is big of n, and this for loop is also running for n times. So big of n plus n, that means big of 2n, and as we ignore the constant part, so apparently we can say the time complexity of this solution is big of n. Okay, and as we were not using any extra space in order to solve this problem, okay, although I'm using an answer vector, this is only for returning it. Okay, so to solve this problem, I'm not using any extra space. I mean, I'm using only constant extra space to solve this problem. Okay, so I hope you have understood this. So we'll meet in the next video with another question of same type based on array marking technique. Okay, so bye bye and take care.